Hi, my name is Greg Young. I'm one of the newest faculty members in the AOE department. My lab is called the Propulsion and Energetics Lab, or PROPEL. In PROPEL, we study combustion for high speed propulsion applications like hybrid rockets, solid fuel ramjets, and solid fuel scramjets. We're also interested in novel energetic materials and how they can be used in these applications. PROPEL spans very fundamental research all the way through very applied research, typically involving high speed propulsion. If we were to start at the beginning, we might consider by starting out by developing novel fuels or ingredients that can be used in fuels and propellants. So here's an example of a nanocomposite of aluminum with an energetic material which we took from an individual particle and wound up formulating in a solid propellant. Once we have materials of interest, we'd like to study how those ingredients or composites ignite and react when subjected to different stimuli on a very small scale to understand the fundamentals. So in the video on the left, you see a droplet of jet fuel that is being ignited by a laser that is about a millimeter in diameter. And on the right, you see an energetic material that's being ignited on a thin platinum wire that is about 75 microns in diameter. And by conducting these experiments on a very small scale, we can optimize materials very early on in their development. And as we learn more about material and how it behaves, we would integrate it into a fuel or a propellant or an explosive, and then we would start to characterize its fundamental performance behavior. So not only are we interested in learning how a material behaves under normal operating conditions, but we're also interested in developing ways to make the materials perform in new ways that increase mission flexibility. And by that, I mean we're interested in developing smart energetic materials and propellants that act on command. As we become more applied, we study how materials will behave at expected operating conditions, but we still keep our eye on the fundamentals. So here's an example of a solid propellant burning at high pressure. If we take a snapshot from a video like this, we can still learn about things like the fundamental surface phenomenon, which gives us insight into the combustion process. And we can continue to build up these fuels and propellants and ultimately demonstrate their propulsive characteristics in motor firings. The main goals for Propel are to conduct fundamental through applied research and develop novel approaches to solve complex problems in high speed propulsion. And at the end of the day, we want to provide a hands on experience for students so that when they graduate, they can be technical leaders in the fields of propulsion and energetic materials. We have ongoing work involving solid fuel ramjets, hybrid rockets, and solid rocket propellants, and we're beginning work in solid fuel scramjets. We're always looking for new and interesting ways to develop experiments to look at materials in a different way. And by that, we've developed recently these levitating droplet combustion experiments. This is a fast growing group. We're looking for two new PhD students to start as soon as possible. Master students are also welcome. And if you have interest in any of this type of work, please feel free to contact me. Thank you.